Have you ever wondered how we can use AI to transform raw data into beautiful and insightful map? I'm going to show you how to do a proper distribution on a contour map using artificial intelligence. First of all, let me show you what a typical map looks like. So let's go ahead and plot water saturation. And then I'm going to show you how to properly distribute water saturation as a function of porosity, phase zone thickness, and any parameter of your choice. Now, let's start first by importing the libraries. We need NumPy for this. We need Keras from TensorFlow. We also need some other libraries like Matplotlib, but let's leave that for now. Next thing we are going to do is we're going to create two things. We are going to create the X data that's going to be used for the interpolation and training purpose, which is going to be the X, Y, and phase zone, and of course we need the water saturation. Next thing that we're going to do is we're going to have our water saturation as a Z value. Of course, in the water saturation from the X data, you can also swap that for porosity as well. That's also a possibility. Next thing we're going to do is we're going to create a scaler because we want to scale the data and make everything in an equal scaling value. Once we do that, now it's time to create the model. The model is going to be a Keras sequential model, so that's going to be a model from top down. First of all, we're going to have our input. That's going to be 64 nodes and activation of ReLU, plus the input dimension is 4 based on the data shape we have. Next thing, we're going to have some hidden layers that are going to be used for calculation and weight updating and activation of ReLU. Next thing we're going to have is the output, which is going to be a single value. That's going to be a regression task. Next thing is to compile the model. So once you compile the model builds its own, and we're going to select the optimizer and we're going to select the loss function. Afterwards, we're going to try to fit the model based on the X and Y data, and we're going to give it a training iterations of 100. Once the model finishes running, next thing we are going to do is we're going to create a deep learning map. Once we call the mapping function, the training process starts again, and now you can see the map that you have generated. It's way more detailed and it's actually properly aware of the other properties in the field itself.